Question 10, we have the velocity in meters per second of a car after n seconds. And we have the sequence 7, 8.2, jump at 1.2, 9.4, jump at 1.2. So it's definitely a linear sequence. First difference is the same, a non-zero constant. Initial velocity of the car, well, the initial velocity here is v0, 7. And what type of motion, describe in your own words, so the type of motion which the car is performing. And we know in these questions we're dealing with uniform acceleration or uniform ACC of, what is it, 1.2 meters per second. Question 10. Question 11, population of unicornia at various dates. It's jumping 0.2, 0.4, 0.2, 0.4, and it's jumping 1.2, and it's jumping 2.6. And they want the differences up to the third differences. Okay, so if we look at the next differences, from 0.2 to 0.4 is 0.2. Just label them, these are the first. Second, 0.2, 0.8 between here and here, and then 2.4. Then we have 0.6 and 1.6, it looks like. And this is when you go and check, and you see that 1.2 to 2.6 is 1.4, not 2.4, and this is 0.6. So this is a cubic sequence. Third difference is the same. And what was the population in 1960 will be this term 0 here. And we're looking for the population in 2020, so we don't need to find the whole Tn. We can work our way up. So 0.6, this number after 1.4 would have to be 2.0, which is linked to this one here. This one would have to be 4.6 for the difference to be 2.0, and 5.5 and 4.6 is 10.1. And term 0, if we keep going backwards from the first difference, second difference, third difference, we will get a 0.6 down here. I'm just going to lay them out a bit neater here just so we can see. I have to work our way back up a bit clearer than the previous. Put the differences in the middle, 0.2, 0.8 and 1.4 gives us that third difference of 0.6. So to work our way back up to the initial, we'd have to have a 0.6 here. 0.8 minus 0.6 is 0.2. 0.2 minus 0.6 is minus 0.4. 0.4 minus 0.2 is 0.2, and 0.2 minus minus 0.4 is positive 0.6. 1.3 minus 0.2 is 1.1, and 1.1 minus 0.6 is 0.5 for the initial, which is what they asked here, the population in 1960, 10 years previous. Then we're given question 12, a polynomial f of x, a function of x, which fits the information given in the following table. Write out the differences up into the third differences, so it looks like we're dealing with a cubic again. So I'll just write them out here, 3, 3, 7, 21, 51, and 103. So 0, 4, 14, 30, and 52. First difference. The second and the third. We've got 4, 10, 16, and 22. Then we have 6, 6, and 6 for the third difference. F of x is one of the following, so it has to be cubic, so it has to be c. We see third difference is the same. The seventh number, we can work our way up. If we put a 6 here, we would have a 28 here. 52 and 28 will be 80, so 103 and 80 will be 183, and f0 we're going in the opposite direction, so just work our way back up to term 0 here. So we'd have a 6, and again following the pattern, that's that one minus that one, that one minus that one is minus 2, 0 minus minus 2 is plus 2. 3 minus 0 is 3, and 3 minus 2 is 1 for term 0.